Hi everyone, welcome back to Investing for Income 101. Today is the first class in our series Option School, and we're going to be talking about time value. Once I learned about time value, all the details, it took me, I've been investing in options for about 20 years, and it took me quite a while to understand this fully. But once I did, it made me much more confident to sell covered call, know what strike prices to use, when to roll the options, and how to essentially increase my profit potential as much as possible. So, what is this class about? So, first, I'll define what time value is, explain the behavior using some charts and graphs, and illustrate how to apply this information for covered call selling. I will also give you an example of how understanding the time value can improve your potential by 20% or even more. So let's get to definitions. So option price, we all know option price consists of two parts. One is the intrinsic value and the extrinsic value. Intrinsic value is really how much the option is in the money, and extrinsic value is the time value that I'll be talking about mostly today. And it's the difference between the option price and the intrinsic value. The time value changes with time, and it gets smaller and smaller as the option comes closer and closer to expiration. Let's look at a few examples to understand this better. So for my examples, the stock price will be at 50. So the underlying is at 50, and we will be looking at call options only. If we have a call option with a strike price of 40, we have two of them, right? Then if the stock price is at 50, the option is at the money or in the money by $10. That's the difference between the stock price and the strike price. So we get the intrinsic value is $10 for both options. And the time value is the difference between the option value and the intrinsic value. So for the first option, it's just $5.60. However, for the second option, if I subtract these two, I get 1580. So this option, the second option, clearly has more time till expiration. When we look at the second set of options, they both have the strike price at 50. Stock price is at 50, so that means they are exactly at the money, and the intrinsic value is zero. So the time value and the option value are actually the same in this case. And for the out of the money options, so for example, if the option strike is 55, which is above the stock price of 50, uh, again, the intrinsic value is zero. The option is not in the money at all, so the intrinsic value is zero, and the time value and the option value are the same. So for at the money, out of the money, the option value and the time value are the same. And for in the money, we just subtract the intrinsic value from the option value. Okay. So at the beginning, I kind of suggested that this graph might not be correct. So is it correct? So the answer is, as usual, is yes and no. It depends, right? So let's look at this at a little more detail. So what this chart is showing us is a time decay of the extrinsic value, or the extrinsic value or the time value, same thing, right? So you can see this is the time value, and as the option nears expiration, it comes all the way to zero. Now, for us, it's interesting how the time value decays. So when there is a lot of time left till expiration, the decay is slow. And as the option nears expiration, the decay is faster and faster. And finally, you can see just a few days, a few weeks before expiration, the decay of the time value is much, much faster. So this is the graph. So is it correct or not? So the truth is, it's correct only for at the money options. So if we have an at the money option, the time value, yes, the time value behaves according to this chart. However, for out of the money and in the money options, the chart is actually quite different. In fact, So if I compare it, the chart for at the money or in the money option for the time value would look something like this. So it starts, yes, it starts decaying slowly, then it speed up a little bit, and towards the end it levels up. So very different from this parabolic curve. So let's look at a little more detail, even more detail. So this is a 3D graph of the time values for a specific stock. It's a theoretical thing, probably obtained from Black-Scholes model. So we have a stock that is at 50, the same as my previous example, and these are different strike prices, 35, 40, 50 would be at the money. And you can see, and this is time till expiration. So this is 50 weeks, this is 10 weeks, etc. Here it's 0 weeks, right? So for the at the money option, which is 50, you can see this parabolic curve all the way expiring till 0, right? However, if you go in the money or out of the money, you can see that the graph is very different, right? It goes down and then kind of it levels up. So very different from this parabolic curve. So how can we use this information for our trading? How can we understand this even better? So what I did, I grabbed the time values of SPY calls on February 17th. SPY closed, that was Friday. SPY closed at 407.26 on that Friday. So I grabbed the bid and ask for all the calls with different expirations. This is 1 week out. This is like 7 weeks out. And I put them into this nice table. How did I get the table? Well, if you look, let's pick one option, for example, 405. All right. So on February 24th, 405 is here. And so the bid and ask is between 496, 499. And the strike price is 405. And the value or the price of SPY 407.26. So from our previous slides, we know how to compute the intrinsic value, right? It's 407.26 minus 405, that's 226. If we subtract the intrinsic value from the bid and ask, we get 270 and 273, right? And the average of the 270, 273 is 2715, which is exactly here. For some later strike price, say March 17 is here. We should get 761. Let's make sure. So 984, 990, the average is 987. And if I subtract again 226, which was the intrinsic value, I get 761. So I took all these data and put them into this table. You can see for the option, say 405 strike price, you can see the time value increasing as there is more and more time left till expiration, right? So if we have, 7 weeks left till expiration, the intrinsic value is 934. If we have just 1 week left till expiration, the intrinsic value is only 27. And that happens for every single strike price. You can also see the strike price. So the option or the time value is biggest roughly around the at the money strike price, right? So the SPY value was 407.26, and for the strike price 407, that's pretty much the closest. You can see this is the highest value, expiration till 1 week, and it's in fact it's the highest value in any column. So that kind of seems to be what we would expect. So let's see if we can chart this. So I can put it into three-dimensional graph, and you can see for the SPY on the right and the theoretical stock on the left, the charts look very similar, right? There is not the sharp peak than one would see on the left, but that's because the strike price and the underlying price don't exactly match, right? We don't have any strike price of 407.26. But this is the highest value at 407, and 408 is pretty high as well. So you can imagine the peak being here. Okay, so these 3D graphs are nice, but they are actually, to me at least, they are not as actionable. So let's take a look and let's see if we can, get more information when we slice the graphs. So if I essentially uh, slice the graph so that I get this chart, that means I have, each line represents different strike price, right? So 217 is right here. So that's 0 week, right, to expiration. This would be 1 week to expiration, 2 weeks to expiration, 3, 4, 5, and 6. You have different expirations from 1 week all the way to 6 weeks. And on the x-axis, we have different strike prices, right? So you can see, as I said before, the time value is the highest for the options at the money. So the time value is the highest for the options at the money. That would be 407, right? And then it gets less and less for as the options go out of the money or in the money, this way. Okay, so for us, as I said, it's also important how the time value is changing. And you can see for the at the money option, uh, the change from week 6 to 5 is relatively small. So the decay is relatively small here, and it gets bigger and bigger and bigger as we near expiration. And finally, the last week, uh, the time value has to go all the way from this value all the way till 0, right? So the decay in the last week of trading of the option is the highest. On the other hand, if I go to say 416 or pick 415, 415 is roughly 2% out of the money. So again, the decay is relatively slow here. Then it gets bigger and bigger. And finally here, between weeks 3 and 2, so the third week is the biggest. Then it gets slightly smaller. And then finally the last week before expiration, it's much smaller, right? So the biggest decline, if you are 2% out of the money, the biggest decline is right here, week 3 and week 2. And finally, week 1, the last week, the decline, the decay is small. So, and the same applies for in the money options as well. So here I have the option value sliced by date. So you can see each line represents a different strike price. So here I have all the strike prices. Actually, I removed some of the strike prices because it was too many. The graph would be too messy. And actually, let me go to the next chart where I even removed more strike prices. And I actually only concentrated on the out of the money options. All right. So the highest line here, that's the at the money strike price, 407. And that would be here. And you can see it kind of follows, again, this is roughly the parabolic curve, that we expect for at the money options. However, if we look at, say, 417, that's this line, you can see it's declining pretty much linearly. The decline picks up a little bit at week 3 and week 2, and it starts actually leveling out already. Week 2 and week 1 definitely much slower decline than the weeks before. So this is really important to understand, and this will help us to decide when to roll. If we are investing into short calls and we want to roll to the next expiration, when is the good time to roll? So one thing before we get to that, I wanted to mention that uh, I keep talking about the decline, the decay of the time value, and in fact there is a special Greek for that, and it's called theta. So theta is the rate of time value decline, and it essentially means how would the option price change in one day. So previously we kind of looked at week by week data. Here you would see day by day. So you can expect this particular option, like the strike price of say 407, would decline by about 21 cents in a day, which means in a week it would be $1.47 or something, $1.40, $45, $1.50, somewhere there. And this option only 15 cents a day, right? So, and theta is always negative because the time value always gets less and less. And you can find, like, theta can be found on better trading platforms. I don't think Fidelity has it, at least I didn't find it, but definitely Thinkorswim has it. And this is actually a screenshot from Thinkorswim. Okay, so what did we learn? So first of all, if we look at out of the money options, which means say 1.5% out of the money or more. So example would be 415, strike price 415, which is about 2% out of the money. So when the option is about 1 week till expiration, that would be right here. If the option is 1 week till expiration, you can see the time value left in the option is very small compared to the previous weeks, right? So it's actually better to roll the option already. Don't wait. Like if you're planning to, continue selling covered calls, then don't wait till expiration. Just buy the option back and sell another covered call. So that's for options which are out of the money. On the other hand, for at the money options, that would be here, say 407. So if the option is at the money, you can see that most of the time value is still left. We still can profit. So if we are selling short covered calls and we are at the money or somewhere near, it's better to hold the option all the way till expiration and get the maximum out of the time value decay. And finally, if the option is in the money, that means somewhere here. So 407, so 399 would be 2% in the money. So somewhere here, you can see the same thing applies, right? There is no point holding, even though it's a little bit bigger here than on the other side, but still, if you have in the money option, then you might as well roll it to options that expire later. Let me now explain what you need to do to improve your profit potential by about 20%. And so normally people would sell out of the money calls expiring in 4 weeks and just hold them for 4 weeks. And the profit would be 446.50. How? Well, here's week 0, 1, 2, 3, 4. So if the option is expiring in 4 weeks and you sell it, you get $4.46 per contract, but per share. So since you're controlling 100 shares, that would be $446. Now, that's the kind of normal approach to selling covered calls. However, if you do something slightly different, not less or more risky, just different, you can get much better profits. So at the beginning, you just sell a call that expires in 3 weeks and hold it for 2 weeks only. So sell the call 3 weeks before, 1 week before expiration, buy it back. So that's after 2 weeks. and roll it to another option that expires in 3 weeks, and then close that second option again 1 week before expiration. So this also takes 4 weeks, but if you look at the profits, so an option expiring 3 weeks before expiration, that's here, and that's $3.40 for the contract. And when we buy it back, that's 70 cents. So altogether, that's $2.70, right? So for 100 shares, that would be $271. But we do it twice, so we multiply by 2. So the profit is $542. Compared to 446, that's 21% more. So essentially here, you buy the option and ride it all the way till expiration, right? So at week 2, at week 4, you're here, and then the option expires. On the other hand, for this strategy, let me see, where can I draw it? Okay, here. So you buy the option, but don't let it go all the way to expiration, and then sell another option, and again ride it for 2 weeks and buy it back. So the profit you get is from the first option is whatever we sell it for, and the second option whatever we sell it for, right? Twice. Whereas here, just the initial money that we get when we sell the option. So this is of course assuming that the stock price is not changing. Always, there is always some fluctuation in stock prices, so these things get much more complicated. But these principles still apply. It's better, take advantage of the biggest declines for out of the money options in week 3 and 2, and then don't wait till expiration the last week. There is really not much time value left, so let's just roll it to the next week or next week. Okay, so what I just wanted to say, all the analysis in this presentation is still theoretical. I use the real option prices, real strike prices, everything was real data, but it all still assumed that the stock price is not changing. So the ETF stays at the same price. In reality, of course, the stocks move up and down. The ETFs move up and down, and so it just gets yet another dimension, and you have to watch for issues, with when the stock moves in your direction or against your direction. But as I said before, the principles explained in this presentation, in this class, still apply. So look at the time value, see if it makes sense to hold your options till expiration, or if it's better to roll them to later expirations. That's all I wanted to talk about. Hope you found it valuable. If you did, please give us a like, subscribe to our channel. There is more presentations or more classes coming up. We also have a series on how to actually do short course selling on SPY options, and so you can take a look at that. And until next time, happy trading.